Okay, so we're going to go ahead and start. Today we have with us Dr. Jakus. He's originally from Nevada. He got his bachelor's from the University of Nevada in 1982. And he got his master's from Colorado State University in Agriculture and Research Economics. He graduated in 1984. After that, he was a volunteer in the Peace Corps in the Gambia, West Africa. And then he got his PhD in economics in the North Carolina State, in the Department of Economics at North Carolina State University. After that, he joined the University of Tennessee, but he decided to leave us in 2001 and he went to Utah State University. He became a full professor in 2003 and head of the Department of Applied Economics in Utah State University in 2008. Most of his research is in non-market valuation of environmental goods, and of course his research has been published in leading environmental economics journals. So without more introduction, I'm going to let Paul start.
All right, thank you very much, Margarita. It's great to be back in Tennessee. It's nice. My wife has longtime connections here. I believe Emmett perhaps knew her as a very, very small child. And my sister recently moved to Western North Carolina, so we still have lots of good reasons to come back. And we always enjoy coming back. Today, though, I want to talk about something that's not actually such an important issue here in Tennessee, but it is elsewhere in the country, and it's the ownership of public land, how it is managed, and what the effect on economic growth is. Now, public land ownership and management is actually quite controversial, particularly out west, if for no other reason that there's just so darn much of it. We have about, I'm going to look at 8 different western states, the mountain states, so pretty much from Idaho and Montana in the north down to Arizona and New Mexico in the south. We're talking 50% of the land is actually retained, owned, and managed by the federal government. It's a lot of land. And western states right now are pretty much involved in yet another rebellion. This happens, actually it bubbles up about every 20 to 30 years. These things bubble up with the western states trying to get the land back. This study was actually, in the interest of transparency, this was funded by the state of Utah, which is perhaps the most pugnacious advocate of getting their land back. The federal government has kept it illegally. We want it back. We can do better. So they funded this. I was pleased to get the project because, quite frankly, I could not be trusted to give the state the answer they wanted. And I told them that up front, and I thought, well, I'll never get this job. And when I outlined the project and told them what the testable hypothesis was, well, we're going to find out if you can really do better. Oh my gosh, the woman in charge of the Public Lands Policy Coordination Office, she's sitting down like this, and she bursts out of her chair and says, but we can do better, we do better, pounding on the table. I thought, oh, well, I'm not going to get this one. But it was great, and as you'll see, actually, it turns out the state has a very legitimate claim. There's some empirical support for that gripe. So, let's see, there we go. Here we go. This is our western states up here, from the Canadian border down to the Mexican and Texas border over here. What we're looking at is lots of public land. The yellow is the Bureau of Land Management. That's primarily low elevation desert. The green is the U.S. Forest Service. 90% of federal land in the west is actually administered by the Forest Service and BLM. So what we're looking at is actually the bulk of land. There are other places that folks out here would know about. This is Yellowstone up here. This is the Grand Canyon. Zion National Park is there. But, outside of these relatively big parks here, National Park Service, which is the land that most people are familiar with, isn't really that big of a player here. Here's federal land ownership. As you can see, some of these states, my home state of Nevada, Chris, are you from Nevada?
No, California.
California, but spend some time there. 81%. Now, if you've ever actually driven across Nevada, you'll understand that no one really wants much of that place. And we'll see some pictures, okay? The minimum is 28.9% up in Montana. Just for comparison, I know everybody here loves the new state logo, so I had to use it. We're looking at just under 5%. On average, the western states have 10 times the public land, federally owned public land, that we do here in the state of Tennessee. Okay, let's see. Now, why so much public land? A lot of this actually is a historical outcome. Tennessee did not have to sign an enabling act to join the Union. So the original 13 colonies, plus a few other states, Tennessee being one of them, didn't have to do an enabling act. But starting with Ohio, and for every state after that, with the exception of Texas, we all had to sign pieces of paper that said we want to be a state. As part of that enabling act, we agreed to give the federal government title and forever disclaim title to that public land, any land that was not already appropriated. If there wasn't a settler on it, if it wasn't already being used, this went back to the federal government, and they owned it. Then in every state's constitution, it says, you will forever and always disclaim title to this land until the federal government shall dispose of it. Okay? Well, they disposed of that land in Ohio, in the Midwest, and even in North Dakota, South Dakota, Oklahoma, and places like that. These states that are right over here, that's Nebraska, all of these states, this federal government disposed of the land, but they did not dispose so much over here in these western states. Now, a lot of that is because simply people didn't want it. It's rugged topography. It hits very high elevations. We're hitting 13,000 feet up over here in this portion of Utah. Where am I? Right over there, in that portion right there. We're talking about west of the 100th meridian, which runs right down about here. We're talking less than 20 inches of annual rainfall. You can have dry land agriculture here in eastern Wyoming, Montana, eastern Colorado, but other than that, it has to be irrigated unless you get it up around 8,000 feet. This land was very difficult to farm. You also had hostile indigenous populations. So lots of different reasons why the federal government hung on to this. Now, the general policy of the federal government was to dispose of the land throughout most of the 1800s and even into the early 1900s. So we had the Homesteading Act. If you could farm 160 acres, you were there for 5 years, and prove that you were there improving the land, the government would then give you title at a very, very, very small fee. Right here, this is actually the Land Grant Railroad. This is the Transcontinental Railroad right there. That's interspersed federal and private land. And so you can see this echoing through to today. The way they financed the railroads was, depending upon the quality of the land, the railroad would get 6 20-mile wide corridors, 3, 6, and 20-mile corridors, depending upon where they were, and every other section of land was given to the railroad. If they could sell that, then they could fund the railroad. Okay? But the feds kept every other section. We literally had a checkerboard out there. The other thing that happened, and all this actually, we're going through all this history for a reason, because these land disposal patterns actually affect economic growth today. The other thing that happened was that states received trust lands. After they signed over all the unappropriated land back to the states, back to the federal government would turn around and deed title to certain sections back to the state as trust lands to be used to fund primarily education in these states. And if you were an early western state, you got 2 sections in every township. So 2 square miles out of every 36 square mile segment. If you were one of the later states, Utah, Arizona, and New Mexico, you got 4 sections. And those were sections 2, 16, 32, and 36. Check out this map. This is Carbon County in Utah. To this day, you can see Section 2, Section 16, Section 32, Section 36. You just go down here. 2, 16, 32, 36. 2, 16, 32, 32, 36. This happens throughout the West. This is one of the largest blocks of state-owned land that's around in Utah. And they got that by basically trying to trade out lands with the federal government, with private landowners, and that sort of thing. So you can see that these little sections are in the midst of, in this orange right here, this is, or yellow, this is BLM land. The green over there is Forest Service land. The state says, we really can't manage these things. It's 640 acres in the middle of nowhere, and we can't get at it. Anytime we try to manage one of these things out here, whoops, let me go back. Anytime we're trying to manage one of these things here, we actually have to go through federal property, and we're subject to federal regulations and not state regulations. So the state says, until I can get this stuff all agglomerated like this, make a nice contiguous, cohesive unit, this is something that I can manage. And so if this is actually rangeland out there, I will guarantee you the state sends no one out there to check on the quality of the forage on that range and how many animals should be put out there and when they are. You know what they do? They say, what does BLM say? Oh, BLM does it, we'll do that too. That's how they manage this land out there. The other problem is, if this is a gold mine, they're literally sitting on a gold mine, and you need to build the road to get to it. The state can't just do that. They actually have to get federal permission. And we'll see that the federal permitting processes are actually quite difficult to work on. Now, what's happened here is we're in the midst of this, how is public land used these days? Well, as it turns out, much of this land you can't use for very much. This is an abandoned ranch just north of the Great Salt Lake. This is not exactly someplace where you can run a lot of cows. This is actually just a little bit further west from there. We're talking 40 to 50 acres per AUN on this land. You need a lot of land to run a 200-acre herd, a 200-head herd, excuse me. You can use it for mining. This is actually down in San Juan County, down in the Four Corners region. This is drilling rigs for oil. There are 8 drilling areas, drilling pads actually in this picture right here. You can use it for that. Fracking has been wonderful for the state of Utah if you're looking at generating oil and gas. The other thing you can use it for is recreation. This is my co-author's husband climbing someplace in the state of Utah. I don't even know where that is. But recreational use, so ATV, backpacking, that sort of thing. Now, the controversy is over how you go ahead and you use this. The state basically says that since 1976, under the Federal Land Policy Management Act, there was this move, a formal move. We are not going to dispose this land anymore. We're going to manage less for commodity output and more for non-market commodities, recreation, ecosystem services. And what the state government says is when you're doing that, we're losing good-paying jobs. We don't have, the coal mines are closing, we're restricted in the amount of oil and gas development that we can do, and we're replacing it with hotel maids. Okay? We're replacing it with bartenders and waiters and waitresses. And those are seasonal jobs, they're not well paid, they're not much in the way of benefits, and you're causing an economic drag with this. If you would let us manage it, we'd get these high-paying jobs, and we generate for those. The counter-argument to that is, wait a minute, when you've got public land and you've got recreation, what you do is you're attracting retirees. You're attracting new types of employment, people who are not necessarily tied in one place. They can telecommute to their jobs. These are good jobs. They are bringing money in. They're not really providing much of a demand on services, and they're raising property values, and you're generating real estate markets and things like that. So those are the two arguments that we've got going on. What we're going to try and do is figure out if that is true. And Tammy, am I supposed to stand in one place? I see you back there moving that. So, okay, sorry, I have a tendency to get my 10,000 steps. Okay. So here are these claims, essentially locked up land in preservation and recreation, you reduce extraction activities, you lose the good paying jobs. The federal planning processes, primarily the National Environmental Policy Act, cumbersome, expensive, and flawed. and we'll see some evidence of that. The states are better land stewards, and here is what drove Kathleen Clark, the director of the Public Lands Policy Coordination Office, crazy when I said, we're going to find out if your story is true. I should have rephrased that a little more delicately. Okay. What we're going to do is there's a literature out there called the regional adjustment literature. It's out of regional economics, which is new to me. But essentially what we're doing is we're saying that we're going to take a look at these measures of economic health. Are they coming to a county or leaving a county? What's happening to jobs in that county? What's happening to income in those counties? And those are going to be our measures of economic health. This is not a new literature. Muth published the first paper back in the Southern Economic Journal a number of years ago, basically looking at employment growth and migration. Greenwood and Hunt in the AER basically developed an endogenous model. These things affect one another. Carlino and Mills did that again. They made it just a little bit more sophisticated. And then in the last 15 years or so, there have been a number of other studies that have done this. These are the ones that have actually looked at public lands policy. Most of these have taken a look at the effect of preservation and wilderness on county growth. And what they have found is that wilderness in a county actually does attract migrants, and it has very, very little impact on employment and income growth. Not very much at all. Wu and Mishra and Eichmann and all, they actually took a look at the Pacific Northwest Forest Plan, which is what was put in place to help manage the spotted owl issues when you're protecting old growth forests. They found some fairly small effects on employment. So employment went down, but you attracted enough retirees and footloose employees to where actually income growth went up. So we've got some empirical stuff on wilderness areas and preservation, but the bulk of the land out there is actually managed for multiple use. And that's where the primary argument is. The Grand Staircase Escalante National Monument, it sits on Kane and Garfield counties in Utah. It's sitting on millions of tons of coal. Low sulfur coal. This is stuff that you would if you're going to burn a coal in a coal-fired power plant, this is the stuff that you would want to use. They're managing it pretty much as a recreation area. This is what drives the state nuts. Okay, that's the stuff we're going to look at, is the multiple use land. Okay. Now, here's just the basic model right here. Essentially what we're doing is we're looking at our values of our economic variables, so migration, employment, income, some time period, some ending period T, some previous time period T minus. The basic idea behind this thing is that we're constantly transitioning toward a stable equilibrium E star. But we never really get there. We transition there at some rate lambda. And then the difference between where we are today and where we started is going to be reflected in that lambda, but we never actually reach that stable equilibrium. There's always an exogenous factor that's bumping us away, and then we move to another stable, then we're moving toward another equilibrium. But what we can do is examine our lambda parameters and say, are we actually on the way to an equilibrium or not? What this does then is if we had two endogenous variables, then we could have a model where one equilibrium value is actually related to the other equilibrium value. This could be jobs, and this could be migration, or jobs and income, etc. We're going to have three. When you finally get down to it, in level form, we would say that what we observe today is going to be a function of contemporaneous other variables. If this is employment, that would be income contemporaneous. This would be lagged employment, and then these would be our exogenous factors. We're going to end up with three equations here, but we're actually going to do it. Oops, I don't have to go there. We're actually, another one here. What we're going to do is we're going to have three equations. Each one of them is going to be in an endogenous system. Public lands is going to affect each one of these. We're going to have other exogenous factors. And I keep thinking the next slide that comes up is the one I want to talk about, but it's not there. There are some econometric concerns here. First of all, we're concerned about error correlation between these. The other thing that we might be concerned about is spatial autocorrelation and then spatial error correlation. So that suggests two different ways that we could go at this. We could use just traditional three-stage least squares. That'll help us capture this cross-equation correlation. And we could model our spatial effects using spatial fixed effects, what the older people in the audience used to call dummy variables. So I did not mean to make eye contact with particular people when I said that. Okay, or we could do generalized spatial economics, and this is the Collegian and Pruka stuff, that actually controls for the endogeneity of the dependent variables, it controls for the cross equation, and you can control for the spatial spillovers. We actually did all of these things. And then and what we're going to see is that we really don't need the spatial modeling. Christian?
Has there not been a lot of exogenous, or well, not exogenous, but changeover in land management in recent years?
No, that's actually a very, very tough question. The answer is not a lot, but we really wish we could have taken care of it. So for example, here, I'm going to go back here with this one.
I was expecting sort of a difference in difference. Or,
well, the problem is we can't get at that measure. When you so what you're looking at, and this would be great if you could do this. So the Grand Staircase, Escalante National Monument would be the perfect place to do this. What happened there? This happened in 1996. President Clinton basically used the Antiquities Act to name that a national monument. He showed up on the south rim of the Grand Canyon, which, by the way, not in Utah, to announce this land management change in Utah, where, you know, his safety could not have been guaranteed had he made this announcement in the state of Utah. And what they ended up doing was they said, we're going to take all this federal land and we're going to manage it now differently. Forget coal mining, we're going to manage it as a recreation area, which essentially this. The state went apoplectic over this thing. Well, what the Clinton administration then did, Clinton basically went to Bruce Babbitt, who was the Interior Secretary at that time, and said, you need to fix this for me. And what they ended up doing was they swapped out a lot of the state-owned land that was within that monument for energy-rich land in other counties in the state, plus a few sweeteners. You know, we're doing X million acres here. We're going to make sure that, you know, we just used up a 500,000 of your state acres. We're going to trade it more than 1-to-1 for you, okay? That would have been the way to do it. I actually thought the state would have this information, that in fact we would know exactly what land got traded where. All they have are summary values. All they know historically is that, yeah, we got this many acres in these 3 counties over here, and we lost this many acres in these 2 counties over here. Dude, I would have loved to have done that. That would have been a great way to do it. That's actually a problem here, because we're measuring our land in the mid-2000s decade, and things change. They do change. As it turns out, though, the land swaps, when you're looking at 550 million acres, the land swaps are a relatively small number. But you're right, we really would have liked to have done that. Okay. So we're going to measure our endogenous variables as density. This is actually, we're taking this from Carruthers and Vias. They were primarily interested in zoning in the West, but the same thing matters with public lands. We're going to take a look at these things and use density measures based on developed land. When you have counties that are 95, 96% publicly owned, that really constrains what you can do for your economic growth and development. And so instead of dividing by the size of the county, we're going to divide by the size of the developed land area, which is what these guys did. And essentially it provides a somewhat better measure of what the county has available. Okay? So in our first equation of a 2-equation system, the way we're going to do this is we're going to take a look at our economic measure, divide by the developed area during that same time period. We'll take the same thing at our ending time period, take the log in order to get a percentage growth. It's going to be related to the contemporaneous density of our other endogenous variables, our lagged density for the endogenous variable we're looking at, and then our public land variables are going to be over here in the ... So we're going to have three equations that look like this. Okay. For our public land data, what we're looking at here, we got it from this thing called the Protected Areas Database in the U.S. Essentially, they call these things the gap status. And I kept trying to figure out what in the world does gap stand for. It's got to stand for something. And all it stands for is knowledge gap. We were looking for the gaps in our knowledge. It's not an acronym for anything. But they had 4 different codes. And different states completed this at different times during the mid-2000s. But gap 1 or 2 basically meant there was a public land that had a management plan that prevented land cover disturbance. We called that protected land. So wilderness, your generic wilderness area, was basically given a gap status code of 2. More protected areas were given gap status code 1, but this was actually very, very small percentage. Your basic wilderness area, your basic national park, that was given a gap status 2. Gap 3 or 4 meant a management plan allowed for land cover disturbance. Gap 3, that's where you could have your coal mines. That's where you could have your ATV recreation. That's where you could log. You could do things like that with Gap 3. Gap 4 meant a management plan did not exist. Gene?
With Gap 1 or 2, could you go in and do fracking where you came in elsewhere and went under? So you're saying disturbance, could you go in?
Possibly. And there's actually in the state of Colorado, in the Pawnee National Grassland, this has actually been, that very issue has been in courts. So the Pawnee National Grassland is up in northeastern Colorado, and it was just permitted that they could frack. They could basically put the well pad outside, drill down, and then go horizontal underneath it. However, the court case was specific to that particular grassland, and the judge wrote a very, very narrow decision. So in general, I don't think so. But clearly, the energy industry is trying to do that. You know, and they would say it's got no effect, right? Okay. So what we're doing is we're looking for these gaps, 3s and 4s. This is what a typical county looks like. This is actually the high Uinta Wilderness area. The ridge up in this thing tops out around 13,000 feet. That would be protected land. We didn't include that in this version of the model that I'm showing you. But downhill of that, this is U.S. Forest Service, multiple use land. Conceivably, this could be logged or it could be used for recreation. This is an early map, so I apologize. This takes tribal land and private land and lumps it together in one category. We actually keep private land separate. That's going to be in our model. There's a state wildlife management area. That's a gap 2. And then down over here, these are gap 3 and 4 over here. And you can still see the checkerboard pattern in the land. That's state parcels in the middle of BLM, multiple use land. We're going to measure multiple use land as percentage of the county, because we have counties of very vastly differing sizes. Nye County, Nevada is gigantic. Story County, Nevada is basically a postage stamp, by Western standards anyway. So that's what we're going to do with this. Our other data, 276 counties in the West. There are actually 281 in our western states, but there's a brand new one, Broomfield, Colorado, that was formed in the middle of our time period by slicing it from other counties. So we had to drop all 5 of those counties out of our data because we couldn't really measure it. But we get it from BEA, census. I'm not going to show the spatial models. I'll discuss them just very briefly. Our weight matrix was actually based on commuting zones. USDA gives us some information. One of the things in this literature suggests that in western counties in particular, you need to be close to an airport. That's going to be a key factor in migration. We're actually going to see some support for that. So we're going to have distance from what are called primary airports. And then we've got some GIS data, the land classification, road density, things like that. Okay? Now, here is our county level land ownership percentages. Our counties, on average, only about 44% privately owned. Some are very urban and very, whoa, sorry, boy. Go back. Go in the wrong direction there. Have instruments, blah, blah. There we go. Sorry, apparently I've got fat thumbs, which anybody who's received a text message from me already knows. What we're looking at here, we got some counties with a whole bunch of private land. We have others. I mean, check that out. 90% of a county. Kane County, Utah is 95% federally owned. Garfield County is 80-something%. The amount of federal land out there boggles the mind if you've spent a lot of time in the east and not much time out west. Pretty much if you're driving down the highway, you're looking around, anything that's not in a valley, you can pretty much be guaranteed it's federal land. And much of what you see in the valley, if it ain't green, it's federal land. Okay? And then states, so what we're looking at then, in our models, these are going to be our three categories right here. So we're accounting for over 80% of the land in our region with just these three categories. We have another set of models where we try to figure out, well, what happens with wilderness areas, what happens with Park Service land. We get the same results everybody else does, but as it turns out, we have a problem with those because all these things are potentially endogenous. It wasn't an accident why this land ended up in the hands it ended up in. The land is rugged, very, very topographically crazy. There's very, very little in the way of water out there, so climate matters. Again, we had those indigenous populations that were out there. So we began to look for ways to try and explain this, to deal with this endogenous issue, and so we went to some instrumental variables. And the variables that we ended up using, we used a measure of climate called net primary productivity. How much carbon can given pixel in our database produce in a given year? That actually is a really good predictor of air temperature and precipitation. We used topography. So we took our pixels, I would say pixel, and we said, well, if we flatten it out, take this pixel, flatten it out, take a ratio of the 90 square meters to whatever the flattened area is, that's going to give you a measure of topography. That if you end up with twice the area, that means it's a really, really steep pixel. We averaged those for the counties. We took a look at the percentage of county that is in non-irrigable soil. That is just junk. It doesn't matter what you do, you can't grow anything on it. Then we looked at protection during the settlement era. As it turns out, U.S. cavalry forts, I learned so much about the West during this project. U.S. cavalry forts, they were strategically located to protect the, what do you call it, like the Oregon Trail, what do you call it, the emigration trails, to protect the railroads, to protect the telegraphs, and also to rescue the settlers from themselves. Okay? Because many people started off, they were completely ill-prepared, and what would they do? The soldiers would not only protect them from the Native American population, particularly down in New Mexico and Arizona, but they would also provide them with provisions. These settlements, these forts, were located actually where they could grow the food for the soldiers, that they had water. So these actually ended up in nice places, and people trekking west would get tired and stop by the fort, which were rarely attacked. Okay? So these forts were in nice places. So we used distance from cavalry forts, which I have to say, that's my favorite instrument that we've got right there. And then finally, we got the amount of trust land that got returned to the states. Some got 2 square miles in every township, others got 4. Our models, this is what it looks like, by the way. This is just down in San Juan County again. Average precipitation there, Knoxville, 48 inches a year. These guys get less than 8. Las Vegas, Nevada gets 4.7 inches annually. Okay, there should not be a city there, by the way, and that's where I grew up. But we're talking very, very dry land. So here are our instrumental variable regressions. We're really quite pleased with these. I've omitted all of the exogenous variables from these models. But as we find out, the feds got the land that was further from the forts. They also got the land, more likely to get the land. The dependent variable is percentage of land in a county managed by the federal government for multiple use. The crappier the land, They got more of it. The more productive it was, the less they got. The more topographically variable it is, they got stuck with that. And then with the Enabling Act, of course, they gave away more land. There's less federal land as you give away more land. That, of course, makes perfect sense. For the state, distance to forts, not really there. Is that economically significant? It's not a huge magnitude on that coefficient, and it just barely misses statistical significance. But they did a good job. When the states were getting the land back from the federal government, and the land was already appropriated, the state got to negotiate with the feds. We think this shows that they were really good negotiators. They were more likely to get land that had decent soil and was productive for agriculture. They also managed to avoid the topographically variable. They managed to get the flatter land. And then, of course, this makes perfect sense here, positive value right there, and that's just a gigantic coefficient. And then with the private land, we also makes perfect sense. They located close to the forts. They got land that is very productive. They stayed in the valleys and out of the mountains. And then this is also negatively related to how much state land was given as part of the Enabling Act. So all of these things look pretty good. Yeah, I'll go with Bert first. Yeah.
With the, you said the states got good land.
Well, it sure looks like it.
Well, yeah, but they got sections 2, 16, I mean.
Right. And so if you think about that, yeah, that's as random as it gets. That's as random as it gets. However, if section 2 ended up in the middle of the valley and there was already a settler there, then the state got to negotiate, where's my other square mile? So they got to actually negotiate quite a bit of this. Whenever one of those sections ended up, someone was already there, we're sitting down around a table and figuring it out. And the states, obviously, they actually wanted places, where it ended up in private hands, that you could farm and that with no mineral value. Okay? And oil and gas didn't matter back then. It didn't matter at all. But we think that this is the outcome of negotiations, because it's consistent with that. We tried to find some historical documents or stuff historians wrote about the settlement in the West to tell us whether or not our interpretation is right. That's pure speculation on our part. Christian?
Convince me that these are going to meet the exclusion restrictions, because I would think that climate and topography and junk soil would also affect growth.
Yeah. Okay. The way I would handle that one is as far as climate and geography. What economic sector are those going to affect the most?
No, it can affect a lot of things.
I would guess primarily agriculture. Okay, particularly if you think about the Mountain West, where we don't have essentially.
I mean, it could affect where people want to live.
Yes, I believe that that's the case. I would say that these sorts of things, so you're talking primarily about the net primary production and the topography. This is a difficult one. I'm going to show you some tests here in just a moment. But I would say that those are going to affect where people settled way back when, which is of course what we're trying to figure out. And I would say that those would affect primarily agriculture. A little less so with mining, because mining, of course, you're going to find a lot of that up in the mountains. But agriculture, as contribution to the state economy and to county economies, in most cases is actually going to be relatively small. I know in certain counties in Utah, it's pretty high. So for example, Beaver County, Utah, by value added, agriculture contributes 20% of that. However, most of that is in confined animal operations, primarily hogs and cattle. So not using a whole lot of land. So that's the way I would make that argument right there, is that you can exclude this because that's affecting agriculture, and it would have been important back in 1900, less important in 2015.
It's still going to affect recreation, and it's going to affect where people want to live when they retire.
Yeah.
It could also affect, medical sector.
Yeah, exactly. So So topographically, if we talk Summit County, Colorado, which is where Vail is, yeah, that's going to have an effect there, okay? But then there we have lots of the ski areas, the destination ski areas that people know about. That's the occasional county. There are lots of counties at that elevation and with that topography that don't benefit from that. So I don't know that statistically it's going to show up. But let me go ahead and show you this right here. Essentially, if we do the partial F statistic individually on these three endogenous variables, we actually, using the stock, right, and Yogo criterion, we reject the idea that the instruments are weak. But if you do the stock and Yogo test, we actually fail to reject that. Okay? Are the instruments valid? So here's, can we have that? Ah, darn it! Do we have that exclusion right there? Okay, because this is your exclusion line. And actually, we failed to reject that for private land, which is exactly what you're saying. That you can't exclude these things. And then, so we have this mixed.
Could you give me some details about the test? Does it take into account the fact that you're using the same instrument set for three endogenous variables, because they're going to have lots of correlation, right, between those three endogenous variables?
This one does, okay? That one does, and if you can tell me how to do these tests better, I would greatly appreciate it. I can only find for this validity test, I can only find a test that does this thing individually for our three. And I don't think you want to do it that way. I think the better way would be if we could find some corollary to our relevance test to this one right here. Either way, though, if you believe that they're weak, if you believe if you believe that they're not valid, then you're still going with OLS, right? You're still going to stick and treat these things as exogenous. When I do the exogeneity test, fortunately, it says that you can treat them all as exogenous, with the exception of the fact that this one is predicated on the instruments being valid, and I got one that says it's not valid. We're stuck in limbo right now. Krishna, I don't know what to say.
I mean, if you wanted to go into a generalized method of moments framework, you could do a joint test.
You can.
It's also, I mean, but it's a general test of specification, so it's not going to tell you where you're going wrong if you're going to go wrong.
Okay, so it'll just say not working, but it doesn't tell you what's not working.
In that context, you could just test whether a set of those conditions are or not.
Okay, could I talk to you about that after this?
Sure.
That'd be great. Okay. All right, so we just go ahead. Essentially what this test is saying here, particularly this one right here, is saying is that the bias associated with doing an instrumental approach is going to outweigh the bias associated with just treating the variables as exogenous. So we go ahead and treat it as exogenous and say, interpret cautiously, you know, the sort of classic weasel way out. But we graphed the data, and this was kind of interesting. This held for all the time periods we looked at and the different economic measures. We end up with these quadratics. So this is income growth as the percentage of a county managed for multiple use and owned by the federal government increases. We see this quadratic. We see an increase for a while and then a decrease. The idea, well, I'll talk about this in more detail in a bit, but this is exactly what the state was telling us. Check this one out. Okay? This one says, as I get more and more multiple use land, I'm going to go ahead, I'm going to have this decrease here, and then an increase over here. Now, the state loved it when they saw this, because this is the argument that says, give us more land. We know how to manage it, but look at this. Past this bottom point right here, this is less than 10% of our sample out there. That's 21 counties that sort of exceed that minimum value. So we've got some potential issues with influential variables, but this thing stayed solid all the way through. And the state, of course, is saying, give it to us. So go quickly run through the model here. The one I'm going to show you is essentially the three-stage least squares one, and this allows holes in the region that the generalized spatial model just doesn't let you have. We ran the models for 2000 2007 as well as through 2010. We knocked it off here because we were concerned about the Great Recession, which absolutely slammed Arizona and Nevada. And as it turns out, I'll just give you the short version here, our models for 2000 to 2007, when you do the reduced form, you get an estimate of those speed of adjustment parameters. That time period, we are moving toward a equilibrium. The models for 2010, they're not. They're headed off someplace else, okay? Which we actually found kind of reassuring, that in the depths of the Great Recession, we ended up, it's not transitioning to a stable equilibrium. It's still trying to figure out what's going on. Gene?
So when you say the Great Recession slammed them, well, Arizona and Utah, I'm thinking it was that housing?
Arizona and Nevada.
Nevada, I'm sorry.
Yeah, housing and employment.
So
And income.
2007 is still including the housing frenzy, but, that was not representative either. So
Yeah, and I don't know how to take that out. But you're right. That included the craziness in Clark County, Maricopa County. I mean, a lot of different places in the West. But it didn't. The recession, I guess, started in December of '07. You're the macro person.
But the frenzy was going on way before.
I know. I recognize that. But we had to stop it. Well, we like those models because it stops right there. It's consistent with what we have.
If you chopped it at 05, you have enough observations?
Well, the observations is not, that's actually not a problem.
Okay.
We could stop it in '05. But if you actually go back even further, in Nevada, it started quite a while ago.
Okay.
It started actually the beginning of this time period. Yeah, there's a lot of issues with that first decade of the millennium. Yeah. Okay. Just a little thing here. When we run these generalized spatial models, we get the same quadratic effect that I'm going to show you here. When we do a test where we impose the three-stage parameters on the generalized spatial model, we do not reject the hypothesis that they are equal to that. So here's the model. These things are all supposed to be positive. We don't get that. We have a few negatives here. So this suggests that maybe it's not as endogenous a system as as economic theory would suggest. These density measures down here are all supposed to be negative. We have both of these negative. That suggests that places that are already dense with jobs and dense with people will grow more slowly. This one here says population density, cities are growing more rapidly. Now what's going on here, what I think is going on here is that in the West you will have cities, so Salt Lake City, Reno, Nevada, Las Vegas, Nevada, Denver, Colorado. They're very, very dense. Their employment and income is employment is growing very, very rapidly. People are living elsewhere. So there's a spatial spillover. And when we capture that in our spatial model, the spatial parameter is definitely there. But that's the only thing that we can figure out is going on here, is that in fact people are living in one county and working in the other county. Does that answer?
No, I was just trying to figure out how to interpret these coefficients. So this is a cross-section model?
This is, 276 counties.
Okay, so this is a growth rate between 2000 and 2007?
Yes, it is, yeah.
Okay.
A growth rate between 2000 and 2007 across 276 counties in the 8 states. Okay, so that's essentially our, darn it, I'll go back here again. That's our explanation on that one right there. And you can actually see it in the data. It's real easy to see. When you map these things out and you say, okay, what's growing positively, what's growing negatively, this was not a surprise at all. Theory suggests it should be positive, but we think the commuting patterns of the West actually are that way. Margarita? Oh, okay. Okay. Let's see, next thing here. We took the ERS county typology variables, and what we see here is that farming counties actually grow a little bit more slowly than other counties. We see that income growth in counties that have a large mining sector actually grow fairly quickly, and this is actually very cool, I think, anyway. Recreation counties, the counties that meet the ERS definition of having a substantial recreation sector as measured by second homes for recreation, measured by hotel receipts, restaurant receipts, location of ski areas, and things like that. They grow more quickly, they have employment growth that's quicker, and they have income growth. This thing held up all the way through both models. In fact, all these results are remarkably stable. It really didn't depend upon the time frame. It's just that, you know, the 2007 one said we're going to an equilibrium. But I thought that one was really cool. Basically, if you got the opportunity to leverage your natural endowments into recreation, do it. Those counties actually rode out the recession a whole lot better than the other counties. We got a few other variables in here as well. I'm not going to talk about these things here. These just come from the literature. Nothing real surprises here. I just want to go straight on to the land ownership variables, given the time I've got left here. We keep that quadratic in the federal on all of our measures. We keep that quadratic in state land ownership as well. Yeah.
Just a clarification question. So were all those variables in the last slide just measured as an average over the
The literature, the way the model is set up, it's beginning period values. Everything goes from the start. And so, actually, I had a long talk. I did this at Arizona State a few months ago, and a couple of folks down there said, you know, you need to have wage growth, you need to have housing value growth in here over that time period. I couldn't put that into the model. I kept trying to figure out a way to where it would generate out of the regional the disequilibrium approach that we're using, and I couldn't figure out a way to justify it and say, oh, we're going to use growth rates here, growth rates is a function of growth rates, and then some of our other ones are going to be beginning period values. I couldn't figure out a way the model would hang together. So those are literally beginning period wage index, beginning period housing values. So we have our quadratic here, and then, let me back up just a bit. So these things held together. These were just rock solid all the way through. Now, what about the checkerboard? That's the second question I wanted to look at here. We went to the landscape literature, and the way we did this, there's this thing called Frag Stats. Let's just say if this is your township, and you get section 2, 16, 32, and 36, and they're completely separate like this. You get 4 square miles amidst a 36 square mile background. The way we have our measure of cohesion is we went to the landscape, we figured, oh, you know, the ecologists have been dealing with habitat fragmentation all along. Let's go look at what their measures are. The basic idea behind this is you compare the area of the habitat that you're interested in our case, state land ownership. You count up the number of edges, and you compare that to the overall landscape. The actual formula has numerator and denominator in the numerator, denominator in the denominator. It's just kind of a pain in the neck, but the idea is this. Okay? Here you would have 4 square miles with 16 different edges, 4 on each square mile, as opposed to if you had a contiguous one, you end up with 4 square miles and only 8 edges. So this index goes up as you get more contiguous like this. It goes down as it becomes more disaggregated. And so we would expect a positive value. If the state's argument is right, we would expect that to grow. And in fact, we use this measure of cohesion, and sure enough, it seemed to work for employment and for income. When for any given percentage of a county that a state owns, the more cohesive it is, the more contiguous it is, the faster that county grows. State Well, I'm not sure the state actually understands this model yet, but they really should be happy with this. Long story short, they were more focused on the dollars of cents. Can we afford to manage all the land if we get it? Not this stuff, which to me was more fundamental, but whatever. So we thought that was really, really cool. Now, if you take a look at this, we begin to get some softening on these relationships over here. Anybody, I've just started reading, I'm trying to figure out, are these statistically significant or not? Or are you one of these people who's like, it's 0, right? The p-value there is 0.12, so clearly it's 0. You know, McCloskey and Ziliak have that book called The Cult of Statistical Significance. They make a distinction between economic significance and statistical significance. Is this just a massive tome to justify interpreting anything I want it to be? Or do you really think it's there? I actually, just looking at these models, we often, and the p-values here, when they soften, depending upon the various specifications we run, this may go up to 0.17 or something like that, 0.19, but it's always staying at a p-value around there. I think that quadratic is there. I think there is economic significance here, even if it's not statistically significant, but we put p-values in there so people can leave it up to themselves and make their own decisions. So I still think it's there. Okay, alternative specifications. We dropped the counties with central cities. Everything stayed the same. Okay, we added state level fixed effects. Well, then we started getting a little bit of softening in that federal effect in migration and employment, just like we saw before, but we keep it in income. Why this quadratic? Well, a couple of different things. First of all, economies of scale. As it turns out, once you've got a federal office out there in the counties, BLM field office in Price, Utah, they are managing the land actually in several counties. You can add 10,000 more acres. They don't need anybody else. They've already got a few guys out there. They've got some trucks. They've got all the equipment they need. Adding 10,000 acres, taking 10,000 acres away, doesn't really affect anything. Okay? So we think that they're essentially, you can, as the as federal ownership increases, there's less and less of an outside injection of funds into those counties. Okay? The second thing that happens are these regulatory-induced inefficiencies, primarily under NEPA, the National Environmental Policy Act. The day we left Utah, Wednesday morning, I did a study on all-terrain vehicles a number of years ago, based on the BLM management plan that was released in 2007, due to be implemented in 2008. Our study was published in 2010. Those BLM management plans have 3 more years to go before they can even think about implementing them. They just had a court decision. They were closing off some areas, they were allowing some areas for ATVs to go, all-terrain vehicles. And they have 3 years to prove that ATVs do no harm in these areas. Essentially what happened, under NEPA, well, they were going to allow ATVs into certain areas. I'll use my right hand for those groups. Okay. The left hand sued them, been in court since 2008. The ruling just came out. They have to study it for 3 more years. I guarantee you that if you would have kept the ATVs out, they would have been sued, and BLM would have been ordered to prove that ATVs do cause harm. Yeah, whatever. The converse, whatever. It's insane. These programs, literally these plans will have been out there for 10 years before you can even begin to change land management. Land is not flowing to its highest valued use. So that's a problem. That explains that quadratic. What about this other quadratic, okay? First of all, we've got the isolation of state sections in that checkerboard. We've got that rational free riding on federal land management that I discussed a little earlier with the grazing situation. And then finally, they don't actually have to do NEPA. A typical oil and gas well in the state of Utah on federal land will take 8 years. A fast one will be like 5 years. An average one will take 8 years. A bad one will take 12 years. A bad one on state lands, is from the perspective of the energy firm, will take 2 years. Most of them are done in a calendar year. I think the average is something like 363 days. It's literally a 1-year process. So that they can actually react to market forces much more quickly on state lands than you can on federal lands. And that's why we think we're seeing that, that quadratic there. But you've got to get you've got to get past this minimum right here. Where are those minimums? Right here, based on that model, we're looking at roughly about 40% for the federal government and about 15% for the state government. But again, one of the problems is we've got very, very few observations pinning that one down. Okay, now, if we did a land transfer, what would we do? And my co-author put this together, which is pretty cool, because there's no way I could do this. But you have to be very, very careful about how you transfer the land. Because over here, if you take federal land away, well, you're actually going to increase economic growth if you move up there. So we're going from 41% down to 31%. But if you're in the wrong county, that means is you could be sliding down the bad portion of this curve and end up at an overall lower growth rate. So what you really, if you really want to do this, you need to be very careful. The one-size-fits-all that the state of Utah is is using, give us all the federal land, we want it back, might not work. It could not work. So you want to actually go county by county and look at it. So, summary here. Basically, we find, I think, relatively strong support for that state's claim that there's too much federal land out there, that it can cause a drag on economic growth. I think we've got support that this checkerboard is just kind of ridiculous. As far as the state's argument that they can do better at fostering economic growth, I don't know about that. So one of the things we're going to do next is try to do some sensitivity analysis. We're going to try and find out, well, what do we have in the way of influential observations? If we go through and try to take a look at that, do we lose these effects or not? But boy, I would want to be very careful about this because we've got some counties. So there are these two counties down in New Mexico, Harding and Luna. They both have about the same amount of state land in it, about 25%. One of them has a very fast growth rate, one of them has a very slow growth rate. Why is that? Got to go and take a look at these things and figure that out. Okay. Again, the endogeneity issue remains. We actually spent a lot of time on that, and I don't think we've got it done yet. And that's a tough one. I don't know that we'll ever do that. All that other literature that we looked at, they bring it up and then whoosh, sweep it under the rug. They don't want to answer it. Yeah.
Is annual data not available in which to do a panel analysis and then control for county fixed effects?
But the problem there is that our land data are just a snapshot. That wouldn't change over time.
I see.
Yeah.
Okay.
So you just have to be like an intercept. Yeah. See? Okay. Yeah.
In your topographic variable, did that have water?
It did not. No.
Because it seems like, percent of the county that's covered in water might be relatively important, isn't it? Or access to water. Because, for example, I'll give you two examples of two cities, Phoenix and Tucson. Phoenix has access to surface water that comes up the mountains. Tucson uses groundwater.
Mm-hmm.
Look at the economic growth of those two cities are dramatically different. And a huge reason is because of having access to surface water.
Mm-hmm.
So I guess it seems to me like that water is such a huge issue out there. I don't know, somehow it seems like that needs to be.
Right, and of course, water is, it's funny, when I stopped being department head, I said, well, there's two things I can do now. I can do public land or I can do water.
Right.
Right? Both of which, will get you shot. No, it's true. It's absolutely true. I thought I was choosing the less controversial of the two, and I'm not convinced. But yeah, with water, but the problem there is we've got these large-scale irrigation projects. The Central Arizona project, the Central Utah project. Nevada is proposing piping all this stuff from groundwater up north and bringing it down to Clark County. Yeah, but that does matter. The access to water matters, and that's almost we're getting into the political economy because Las Vegas, Phoenix, particularly those two, and they're the only entities that have the weight to actually fight California on the major water sources in the West. So. But we're trying to explain how it ended up in private hands. And back in settlement times, essentially all this land that ended up in private hands, 97% of federal transfers to private hands occurred before 1940. Bureau of Rec got going in the late 20s, late teens, really, early 20s before they started.
Don't you think what kind of water access they had at that point would have had some influence on
Yes,
the
but
transfer?
but they didn't have much in the way of large-scale water transfer projects back
Yeah.
there.
So it might be more of a natural,
Oh,
whatever was there.
Okay.
naturally.
Yeah, okay, so this is actually, Wolfram Schlenker did a variable where they tried to measure access to water. And the way they did that was actually measuring the slope of the surrounding area around a town. And essentially what it boiled down to is if you're in a valley, that's where we ended up with private land. And we sort of do the same thing, but it's not quite the same as that. Okay. Got just one more thing here. We have some alternative modeling approaches. As a matter of fact, I was talking with Brad Wilson about potentially going down to the Puma level, which is a smaller or can be a smaller geographic unit than a county. Kerry Smith suggested a varying parameters approach. We looked at that. Not promising to begin with, but it's still need to take a look at that a little more closely. And I want to talk to Christian about maybe trying to do, see what we can do with the GMM to help us with our endogeneity problem. And that is it.
Any other questions? If not,
All right.
just
Thank you very much. I think that's it. There we go.